Okay, so in this video let's talk about the first law of thermodynamics. This is very interesting topic. First of all, you need to understand two terms. One we call as the system. System is the place which we are interested in, right? It can be a machine, it can be a biological environment, likewise, which we are focused on, which we are interested in, and all the other things surrounding it we call as surrounding. Now the relationship between the system and surrounding is very interesting. There are three types of systems. The first thing is open system. So in this case, in open system, you need to know that both the matter and heat, or we can say energy, both the matter and energy, both these things can move to each other. Like the matter can be transferred from system to surroundings, or matter can transfer from surroundings to system. Energy can be transferred from system to surrounding, or energy can be transferred from surroundings to system. Likewise, both these two components can transfer between these two border, between this border. This is called the open system, both matter and energy. Okay, and second one is we call as closed system. Okay, in closed system what happens is the matter cannot be transferred. No, through this border the matter cannot be transferred, only the energy can be transferred through this border. So in closed system, okay, in closed system, this system border doesn't allow matter to be transferred, only the energy can be transferred. And the final one is the isolated system. In this case, both this energy and matter, both these things can't be transferred. So in isolated system, okay, the system is completely isolated. It means there are no contacts between the surroundings and system. Now let's look at why we are talking of such these terms. Okay, now the internal energy, this is an important term. Basically the internal energy means the energy which this system contains. This is called the internal energy. So in first law of thermodynamics, what the scientists have told is the energy cannot be destroyed. No creator. Energy cannot be destroyed or energy cannot be created. This is the first law of thermodynamics. Only thing the energy can do is it can transfer from one shape to another, right? It can act as a heat and it can transfer into like work, it can transfer into electric energy, potential energy, kinetic energy. Likewise, it can change its shape, but it cannot be destroyed or it cannot be created. This is the first law of thermodynamics. And now we have introduced this term internal energy, which means the energy which contains in this particular system. Okay, the internal energy means all sort of this type. There are so many energy types, like I have told you, like potential energy, kinetic energy. Now all these energies, okay, all these energies inside of this system we call as internal energy. So internal energy contains all the type of energies which this system has. Okay, Now we have an equation which describes this first law of thermodynamics. It is like this. Now this internal energy, okay, this internal energy can be described by Q plus W. This is the internal energy. But what is this? This means this is the delta U, which means the internal energy difference. Okay, internal energy difference. This internal energy difference is based on the Q, which means this is the heat. Okay, this is the heat and this is the work. But this is not sufficient. Okay, this is not sufficient. This part is very important, so listen very carefully. Okay, the Q, I have told you the Q is the heat, but not just heat supplied to the system. Okay, heat supplied to the system. Work is, this W is not just work, it is work done on the system. This is very important. Work done on the system. Why is this important? Like, you know that system can do work on surroundings, right? Most common example is, let's say you have put some object. Here you have an object and you have pushed it for 7 meters. Now you have done the work, right? You have done the work, which means you have supplied the energy. So when you have done the work, when you are doing the work, you are supplying the energy, you are releasing the energy. So your internal energy should be reduced now, because you are doing the work, you are releasing the energy, you are giving the energy. So your internal energy, your capacity here in your system, okay, in your system there is a capacity, there is an amount of energy you have. So when you are doing the work, what happens is you are going to release this energy. Okay, and work done on the system means someone is giving you the energy. Work done on the system. Okay, so this W means work done on the system. Okay, the work done on the system. If your problem or if your situation is based on the, you are the one who doing the work, the system is the one who is doing the work, then this W is a negative one. Right, the opposite, complete opposite. Okay, so this W is negative. Okay, this W is negative when you are the one who are doing the work, when system is doing the work. So we have introduced this W term as work done on the system. So it's basically positive. If someone is doing the work on the system, then it's completely a positive value. If you are the one who is doing the work, if system is doing the work on surrounding, then our definitions opposite happens. So this should be negative. Same thing happens for the Q. So basically the heat supplied to the system. If the system is the one who is supplying the heat to surrounding, and then the Q becomes negative. So this is very important. This equation and these terms, okay, these are very important facts. I hope you got this idea. Okay, so let's look at some examples so you can easily understand this particular thing. Okay, so here we have a small problem. A system has done 5 joules of work and released 10 joules of heat. Calculate the delta U of the system. Okay, now look at this. We have the system. System has done the work. Okay, system has done the work. Now what happens when system is doing the work? So system's internal energy should be reduced, right? System's internal energy should be reduced. Why? It is the one who is doing the work. It gives energy. So our W, okay, our W should be a negative value. Right? System has done the work. If someone is doing the work on the system and then it's completely okay, here work done on the system, completely okay, then it's positive. But in this case we have the work of negative 5 joules. And heat, look at the heat, released 10 joules of heat. It has released 10 joules of heat. So our Q should be negative 10 joules. It has released from the system. Okay, it has released from the system. So now we can use our delta U equals Q plus W. Q is negative 10 joules and W is negative 5. Our total is 15 joules. This is not the internal energy, right? This is not the internal energy. This is the difference between the internal energy. So initially, before this thing happens, our initial system has a U1 of energy, and after the system has done this work and released this energy, our system has U2 of energy. The difference between these two values is the negative 15. That's what we have taken from this equation. Delta U, the difference between the internal energy. How much of internal energy has changed during this particular function. Okay, so let's take another quick example. This is the most common example. Let's say there's a piston over here. Okay, there's a piston over here, and here you have a gas. Now this is our system. Okay, this is our system. Now look at, let's say when this piston is being pushed outwards, right? What happens now if this piston is pushed outward by our system? Okay, then who has done the work? System has done the work, right? System has done the work. Then if the system is doing the work, then the W should be negative. If we are using a force and pushing this piston towards to our system by compressing the gas, then who is doing the work? We are. The surrounding is the one who's doing the work. Surrounding is doing the work on the system. Now in that case, we have a positive W value, right? So when we are doing the work on the system, we are giving it the energy. So basically the internal energy accepts all kind of energy types, right? It can accept heat, it can accept work, but it stores those energy as internal energy. So when we are doing the work on the system will take that work and store it as internal energy. So it can use those internal energy to do work. Okay, that's the main thing, right? So I hope you get the idea about this work, heat and internal energy. This is very important when it comes to thermodynamics.